Okay, now let us take few practical scenarios which we observe in our day-to-day life. For example, when you are suppose riding a bicycle and you take a turn, you have to decrease your velocity at times, right? Otherwise, there will be a skid. Fine. So let us take such scenario. For example, there is a car. There is this car which moves in a circular path, and it has velocity v at a particular instant. It takes a circular arc of radius r. Coefficient of friction between the tires and the roads is suppose mu, and it has the entire car's mass is f. Okay, we need to find out relation between these three parameters so that the car do not skid on the curved path. Now, which direction the car will skid? If you observe with respect to car, then the car will tend to skid outwards. Okay, so let us draw free body diagram of mass m. If this is mass m, suppose uh, this is mass m and it is moving a velocity v. Now the normal reaction between the wheels and the road will be what? Now normal reaction will come out of the board, so I can't draw it right now, but I know that if I take my z-axis as coming out of the board and I write down Newton's second law of equation, sum of all forces along z direction is mass times acceleration along z direction. Then along z direction there is no acceleration, so normal reaction which is along z direction minus mg will be equal to 0. So normal reaction will be mg only, and since it is moving in a circle, so it must have centripetal acceleration v square by r. Right? Now, one thing we need to be very mindful here is, since there is an acceleration, there must be a force which causes this acceleration. Okay, and what is the force which is creating this acceleration? That force is frictional force. No other force will be parallel to the road. Okay, so this is, I'll draw frictional force as this and say this friction is equal to mu times n. Okay, now if it is just about to skid, right, so friction force will have the maximum value mu static times n, right? So at limiting condition, frictional force, let me write down like this. I will write down, this is my x-axis, this is my y-axis, and perpendicular to board was my z-axis. Sum of all forces along x-axis, if I write down this equation and I take direction of acceleration to be positive, then mu static times n, which is the force, must be equal to mass times acceleration, which is v square by r, right? So normal reaction is what? mg. So mu s m into g must be equal to m v square by r. So m get cancelled. So v square is equal to mu s rg, or v is equal to mu s r into g. Now this is a limiting condition. This velocity is the maximum velocity. If you have more velocity than this, then friction force will not be able to provide this much acceleration, because see, frictional force will be fixed, mu mg, and if you increase the velocity, acceleration will increase. Now this friction cannot cause that acceleration. Okay, so what will happen, since velocity you have increased and it is not able to support this much acceleration, it will increase the radius. It will skid in such a manner that radius increases to compensate the increase in velocity. Okay, so that is why it will move slightly outwards. Okay, fine. So this is maximum velocity. Now if velocity is fixed and you want to find out what the minimum radius to which you can take a turn, for example here you can increase the acceleration by reducing the radius also, right? So even that you can get from here. The radius must be equal to v square by mu g. Okay, so this is minimum radius. If your radius is less than this particular radius, then your acceleration will become large and friction won't be able to support this much acceleration and your car will skid.